Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Okay, so we'll start with the class. So we were discussing about the types of chemical reactions, right? So we have completed combination reaction, decomposition reaction, displacement reaction, then double displacement reaction. Last class I had just revised all. Okay, then we had started with oxidation, reduction, and redox reaction. So oxidation with respect to oxygen and hydrogen, right? Same with respect to reduction also. Now, what is redox reaction? Can you tell me what is redox reaction? Redox reactions are those reactions in which simultaneously oxidation and reduction takes place. So redox reactions means what? Simultaneously. Okay, at the same time, in the same reaction, what will take place? Oxidation as well as reduction takes place. Okay, so that is called as redox reactions. Okay, so here is the definition. So you can see here, last class we had discussed about redox reaction. So what are redox reactions? So in the same reaction, oxidation and reduction both takes place simultaneously. Then they are called as what? Then they are called as redox reaction. So then we were discussing about what is oxidation and reduction. Oxidation in terms of oxygen. Okay, whenever you are adding oxygen, then it undergoes oxidation, right? So we had discussed this definition here. So what is oxidation? You can see here what is oxidation. So addition of oxygen. Addition of oxygen is nothing but what? Addition of oxygen is oxidation. Okay, addition of oxygen is oxidation. Or removal of hydrogen is oxidation. So either addition of oxygen or removal of hydrogen is what? It is oxidation. Okay, and what is reduction? Reduction is what? I can just write addition of hydrogen, okay, and removal of oxygen. Removal of oxygen. So that is reduction. Okay, so when you are adding hydrogen, it results into reduction. And what is redox reaction? So the redox reaction is the reaction in which simultaneously oxidation and reduction takes place. So in one reaction itself, what takes place? Oxidation and reduction takes place. Okay, so they are called as what? They are called as redox reactions. Okay, so these were the reactions we had discussed. So displacement reaction also I'll just explain. So what are displacement reactions? So whenever, so you can see here example, zinc plus HCl giving you ZnCl2 plus H2. So what is happening? The more reactive element, okay, there are two types of element here. One is more reactive than the other. So the more reactive element, what will happen? It will get displaced, okay, with the less reactive element from its compound or the solution, then it is said to be undergoing a displacement reaction. So we had discussed the examples also. Then what is double displacement reaction? In double displacement reaction, what is happening? The ions are exchanged between two reactants. Okay, the here in this type of reaction, the ions are getting exchanged between two types of reactants, forming new compounds. So they are called as what? They are called as double displacement reaction. So the reaction in which the ions, okay, so here you can see BaCl2 and Na2SO4, that is barium chloride and sodium sulfate. So what is happening here? Two types of ions are getting exchanged. That is Cl is getting replaced by sulfate. So Ba sulfate, that is barium sulfate is formed, and sodium chloride is formed, right? So the ions are getting exchanged between the two reactants. So two types of ions are getting exchanged. So it is called as double displacement. At the same time, between the two reactants, the ions are getting exchanged. So it is said to be double displacement reactions. Okay. So we had discussed about double displacement reaction, what is oxidation reaction, what is redox reaction, okay, and what is this reduction reaction, oxidation, reduction, and redox reaction. Now, what is oxidizing agent? Okay, what is oxidizing agent? The substance which gets reduced is called as oxidizing agent. Okay, so the reaction, okay, the reaction in which the substance is getting reduced, okay, then it is called as oxidizing agent. And the substance in the reaction in which the substance is getting oxidized, then it is said to be reducing agent. Oxidize means what? There will be loss of electron. Okay, so there will be what? It is getting oxidized. So it is said to be, it is undergoing a reducing, it is said to be a reducing agent. So remember this two definition, they'll not ask you, okay, this is for your higher studies, but just remember. So what is reducing agent? The substance which gets oxidized is reducing agent, and the substance which get reduced is called as oxidizing agent. Okay, so so these were the examples we had discussed earlier class. So we'll go for the next. So next we'll discuss what is exothermic reaction. Okay, what do you mean by exothermic reaction? So reaction in which produces energy is called as exothermic reaction. Okay, so most of the decomposition reactions are exothermic in nature. So always the reaction which produces energy. For example, I had said you once that NaOH, okay, sodium hydroxide pellets, so they will be like camphor, okay, they will be in the form of camphor. So when you dissolve, if you take a beaker and if you add water in that, and if you try to dissolve the pellets of sodium hydroxide in water, okay, what will happen? The beaker, if you touch, okay, after adding sodium hydroxide, it will become hot. Okay, why? Because the energy is produced. Okay, the reaction is occurring, it is giving out energy. So it is said to be exothermic reaction. Okay, you can observe, you can you can feel the heat. Okay, so it is called to be an exothermic reaction. So always most of the decomposition reactions are said to be exothermic in nature. So for example, respiration process, respiration. So whenever you are inhaling and exhaling, you can feel that there is you are producing heat, right? Whenever you are inhaling and whenever you are exhaling, you can see, you can sense that you are producing heat, right? So that is nothing but exothermic reaction. So these are exothermic reactions. So respiration process, respiration means taking of oxygen and giving out of carbon dioxide. Okay, so this is example for respiration process. So that is a respiration process is example for exothermic reaction. So what are exothermic reactions? So reaction in which they produce energy in the form of heat. Okay, so here the energy is produced, so you can feel the heat. Okay, you can feel the heat. So as I gave the examples of sodium hydroxide, so when you have added it to the beaker, okay, so what will happen? The beaker, you'll feel it as hot. Okay, so that means what? The it is undergoing exothermic reaction. Now next is endothermic reaction. Endothermic reaction means what? A chemical reaction in which heat energy is absorbed. Okay, it is absorbed, is called as endothermic reaction. So in this type of reaction, whenever you touch, okay, whenever you any reaction, okay, so it will be cold in nature. So the heat energy will be absorbed. Okay, the heat energy will be taken by the solution. It will be taken by the reaction, whichever the chemical reaction is occurring, the heat energy will be taken by it. So if you are holding the beaker, if so sodium chloride, okay, sodium chloride, if you stir it with water, if you touch the beaker, you will feel it as cold. Okay, as cold as ice. Okay, so it will be endothermic. Endothermic means what? Heat will be absorbed. Okay, so heat will be absorbed. So your, when you touch the surface, okay, of that reaction, chemical reaction in which it is occurring, it will be cold in nature. It will be cold in nature. For example, here it is given as calcium carbonate. Okay, when calcium carbonate is heated, so it will give out calcium oxide plus carbon dioxide. So this is a endothermic reaction. Okay, so this is exothermic and endothermic reaction. So exothermic reaction, what happens? Heat is produced. Okay, here heat is produced, and in endothermic reaction, what is happening? Heat is absorbed. So heat energy is absorbed. So these are the another two types of reaction: exothermic reaction and endothermic reaction. Okay, then next comes is corrosion. Okay, what do you mean by corrosion? So you must have seen iron articles Okay, iron articles, nail. Okay, suppose nail, any your iron, the gate, okay, gate of your house. So whenever it is new, so it will be having a shiny surface. Okay, but as if you don't coat it for a longer time, so as the time passes, okay, maybe due to moisture, due to may it might have come in the contact of air, okay, or with water by the rains. So what will happen, the iron, it starts getting reddish brown color, right? The iron which will be having it will be having a metal shine surface, so it will it goes, okay, as the time passes, it tries to the shine disappears. Why? Because there is something process called as rusting, okay, rusting of ion. So if you leave the iron like that only, okay, to the air or atmosphere, okay, so what will happen, the air which is present in the atmosphere, or the moisture which is present in the atmosphere, or maybe due to the water rains, okay, so what will happen, the iron, it starts getting rusted. Rusted means what, there will be a formation of reddish brown color powder. Okay, so if you leave the iron for a long time unused, okay, without any coating, so it becomes there's a process called as rusting of iron. It undergoes rusting. Okay, so only the gates, okay, the gate in front of your house, they paint. Why they paint? Because it should not corrode. Okay, so this rusting of iron, so slowly, okay, if you don't remove the rusting, so it undergoes corrosion. Okay, corrosion means what? Corrosion is another process. Corrosion is nothing but, so slowly. So if you do not stop the, okay, if you do not take care of the metals, so what will happen? The slow conversion of metals into their undesirable compounds. So what happens? The metals, if you keep it unleft like that only without any, okay, so what happens, due to the reaction with the oxygen or the water or the acid gases which is present, etc., in the atmosphere, okay, it leads to corrosion. It starts getting erupted. Okay, it starts getting erupted, so it gets reddish brown cover on it. Okay, so that is called as corrosion. So corrosion for your car bodies, okay, so corrosion, it causes damages to your car bodies. Okay, so the parts of the car. Then for the bridges, so bridge also, it consists of what, it is made up of iron, right? So the iron should be prevented from the corrosion. Okay, so so it will be coated. So the iron which is used in the bridge, so it will be coated, or because of that corrosion, what it will do, the iron, it starts getting rusting. Okay, so it's the life of the iron, it gets spoiled. Okay, so because of that, so the bridges, then iron railings, okay, the railings which are made on the bridges, so iron railings, so that also should be prevented. So these so the corrosion, it will damage the surfaces. Then ships, so ships also are made up of iron. Okay, so here everywhere, so the it is made up of metals. Okay, so metals, so especially the metals means like iron, so all these are made up of metals like the iron. So corrosion of the iron is very serious problem. Okay, because so every year, to avoid corrosion, so because because of that, so many this enormous amount of money will be spent, okay, to replace the damaged iron. So for this bridges, okay, railings and also enormous amount of money will be okay, it will be put on that, because to avoid the corrosion. So corrosion is nothing but rusting of iron. So if you do not coat the iron, if it is left like that only, okay, for a very long time, it starts getting corroded. It starts getting corroded. Okay, so it gets a reddish brown flame. So why it gets? Because it gets reacted with the oxygen, air, water, or gases which is present in the atmosphere. Okay, so that is nothing but corrosion. So corrosion is nothing but slowly it start getting the metal which will be having a good shiny surface, the life of the metal, it starts getting erupted. Okay, it starts getting degraded. Why? Because the oxygen, the air which is present in the air, it starts spoiling the iron. Okay, so this is nothing but corrosion. Corrosion is it is nothing but it is a very slow process in which it converts the metal into an undesirable compounds. Okay, so this is corrosion. So you can see here. So for example, corrosion of copper. So copper, okay, here you can see copper. So if you keep the copper, okay, copper, if you keep it unclean, so it gets corrupted to green. You can see here. You can see in this diagram. Yes. So it is getting corroded to green color. So the copper, okay, it will be copper, okay, coppery shine. It will have a shine. So it turns. So if it is left like that only, so with the, so you can see copper when it reacts with water, okay, so it becomes cupric oxide, okay, Cu2O. So this is cuprous oxide, so it becomes green in color, okay, it will be green in color. So this, it leads to the corrosion of copper. Then another example is corrosion of silver, okay, silver also, silver articles, you can see here silver articles. So silver articles also, if you do not clean it, okay, if it is left unused for very long time, if it is left like this only for the surrounding with the air, okay, or the gases which is present in the atmosphere, you can see here silver oxide, if it reacts with H2S, that is hydrogen sulfide, it forms silver sulfide, okay, you can see here the articles, it has been turned like this. So this is nothing but rusting or corrosion, okay, it forms corroded. So the articles or the metals, it gets corroded. So this is examples of corrosions of copper, and this is example for corrosion of silver. Okay. So next is rancidity. So rancidity means, so whenever you taste, so that is undesirable change that takes place in oil containing food items due to oxidation of fatty acid. Okay, rancidity means, so whenever some foods, okay, some foods they are left, they will smell. Okay, so whenever if you might have tasted or you might have smelled the fat or oil containing food, okay, or food materials which are left like that only for a very long time. So the fats, okay, the fats or oils, so why oil or fat is added for the food, so that it should live for a longer time. So to 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 prevent the food for a longer time, okay, so the validity of the food should remain for a longer time, so they add what, they add oil or fat, okay, they add oil or fat to the food material, so that it will remain for a longer time. So whenever fats and oils are oxidized, so they become rancid, okay. So whatever the oils and fats, whenever they are present in the food, so they get oxidized. So what will happen, the food become rancid and their smell and taste change. So because of the oils and fats which are present in the food, so what will happen, the oils, it will start oxidizing, and the food, the taste of the food and the smell of the food, it changes. Okay, so usually the substances which prevents oxidation, so to prevent such oxidation, what is added, antioxidants are added. So antioxidants are added to the food material, so that to prevent the oxidations, okay, which is occurring due to the oil and fat which is present in the food materials, so that it should live for a longer time. So to prevent the rancidity, so that the taste and smell should not change, so what they add antioxidants are added for the food material. Rancidity is nothing but there will be the change of the what you say, the food material gets spoils, okay, the food material gets spoils. Why? Because the oil which is present or the fat which is present in the food item, it starts getting oxidized. Okay, there will be change in the smell and the taste of the food. So because of that, the food become rancid. Okay, rancidity, it is said to be rancid. So so to prevent that rancidity, what is added, antioxidants are added to such food, so that what will happen, so so and so antioxidants are added to the food materials, and the food materials which are which are supposed to be stored for a longer time. Okay, so they are kept in a airtight container. So they are to be kept in airtight container so that there should be no passage of any air. So it should be stored in a airtight container, and there should be no air. So there should be no air. So you have to flush out all the air. And so for example, the chips, okay, chips packets, what you eat, right? So the bag, okay, the chips packet. So the chips to remain for a longer time, what is added in that? Nitrogen gas. Okay, so to they flush out the normal air, and they put nitrogen gas. So nitrogen gas here, it acts as a antioxidant, so that it prevents the chips, okay, the potato chips which will be present in the packets. So whatever the, so because of that, the packet will be fluffy in nature, right? It will be fluffy in nature. Why? Because whatever the normal air is there, so they just remove out and they blow in what? Nitrogen gas. Okay, nitrogen gas is been blown so that the chips do not get oxidized. So here the nitrogen gas is acting as a antioxidant. Why it is because the chips, potato chips, they should not get spoiled. So because of that, nitrogen gas. So here the antioxidant which is used, it is nitrogen gas. So whenever, so to avoid the rancidity of the food materials, okay, which is containing the oils and fats, so what is added? Antioxidants are added. So antioxidants, what is the role of the antioxidants? So they help to prevent the food for a longer time. Okay, and so whenever you are adding the antioxidants, so the food should be stored in a airtight container, and there should be no air. So when like for the food items like the chips in the chip packet, so all the air has been flushed out, and here what is added as antioxidant? Nitrogen gas, so that they prevent the chips or the food materials to be preserved for a longer time. Okay, so this is rancidity. Okay, so this is rancidity. So by this, we have completed our chapter, okay, that is chemical reactions and equations. So till now, what all we have studied, we'll just glance over. So what all you have studied till here, okay? So till now, you should have a quick idea that what is a chemical reaction, okay? A complete chemical reaction, how to write a complete chemical reaction, how to represent, that is what is the reactants, what are products, okay, and how to write their physical states. So you should be having a idea about what are chemical reactions, okay, how to represent the chemical equation, how to write the what are reactants, okay, what are products and their physical states, how to write it symbolically. So you should write this. Then next is what? How to write a chemical equation, a balanced chemical equation. Okay, so that balanced chemical equation means what? Across the arrow mark, okay, across the arrow, and okay, that is across the arrow, to your left hand side will be your reactants, to your right hand side will be your product. So the number of atoms present on the reactant should be equal to the number of atoms present in the products. Okay, so this is a chemical equation should be balanced, so that the number of atoms of each type, okay, each type involved in a chemical reactions are same on both the reactant as well as the product sides of the equation. Okay, so always the equations must be balanced. So you have to see that equations should be balanced. Okay, so this we have studied. So we have studied about chemical reactions. Okay, then we have studied about how to write the chemical reactions, what are reactants, right? So what are reactants? What are reactants? What are products? How to write it symbolically? How to write the physical state symbolically? Okay. Then next is how to write the balanced chemical equations. In balanced chemical equations, what you have to see, the number of atoms which are present, which are involved on both the side, that is on the reactant and the product, should be equal. The equation must be a balanced equation. Okay. Then after that, we had seen what are the types of chemical reaction. So the first is combination reaction. What do you mean by combination reaction? Combination reaction, two or more substances combine to form a single product, right? So combination reaction, two or more substances, they combine to form a single substance or single product. So it is said to be a combination reaction. So based on this, we have seen different examples. Okay. Then next was decomposition reaction. What is decomposition reaction? So these are opposite to that of combination reaction. Why they are opposite? Because here decomposing reaction, a single reaction, what will happen? It will decompose to give you two or more substances. So in combination reaction, two or more substances would combine to give you a single substance. But in decomposition reaction, it is vice versa. Okay, it is reverse or it is opposite to that of combination reaction. Why? Because here in decomposition reaction, a single substance will decompose to give you two or more substances. Okay, so it is said to be a decomposition reaction. Then we had discussed about a displacement reaction. Okay, what is displacement reaction? Whenever a element displaces. So in displacement reaction, element which is more highly reactive, okay, so that will get displaced with the metal, okay, or the element which is lesser reactive. Okay, so from its compound thus it is called as a displacement reaction. Then we had discussed about double displacement reaction. What do you mean by double displacement reaction? Double displacement reaction, double displacement reaction. So double displacement reaction. So two different atoms or groups of atoms. Okay, so in double displacement, double means what? At the same time, two different atoms or groups or ions are exchanged in double displacement reaction. Okay, double means two. So at the same time, two atoms or groups or two ions are exchanged. So they are called to be a double displacement reaction. Then we had seen something called as precipitation reaction. Precipitation reaction means what? Precipitation means what? PPT. What do you mean by PPT formation? PPT formation means it will be form of a curd. Curd like insoluble salts. Okay, they produce insoluble salts. So PPT reactions or precipitate reactions are nothing but they form a curdy precipitate. Okay, curdy form. They'll be in the curdy form. They are supposed to be in the curdy form, so they are called as insoluble salts. Okay, so because they are insoluble salts, so they form curdy precipitate. Then next we had discussed about what is oxidation, reduction and redox reaction. What is oxidation? Addition of oxygen, removal of hydrogen, okay, is called as oxidation. What is reduction? Addition of hydrogen, removal of oxygen is reduction. What is redox reaction? Redox reaction is a reaction where simultaneously oxidation and reductions are taking place. So in a reaction simultaneously when oxidation and reduction occurs, they are said to be a redox reaction. Then we had discussed about what is exothermic and endothermic reaction. Exothermic reaction means what? Exothermic reaction means whenever the reaction in which heat is given out, okay, the reaction in which heat is given out along with the products are called as exothermic reaction. So you can see the whenever the chemical reaction, if you see that the chemical reaction heat is given out, okay, then it is said to be exothermic. And what is endothermic? Heat is absorbed. Okay, heat is absorbed. It will be cold. It will be cold. It will have a cold effect. It will have a cool effect. So reactions in which the energy is absorbed are called as endothermic reaction. Okay, so these are the types of reaction we had discussed. Then today we had discussed today we have discussed about corrosion. Okay, we have discussed about corrosion and rancidity. Okay, so these are the important subtopics in this particular chapter. So if you have any doubts, you can ask, or we'll start with the in-text questions. Okay, I'll solve the in-text questions. So we'll go with the in-text questions. If you have any doubt, you can ask, or we'll go with the in-text questions.
No doubts, ma'am.
No doubts, ma'am.
Oh, okay, fine. So we'll start with the in-text questions. So these are the questions in the textbook. Okay, first we'll solve the questions from the textbook. Then we'll go with the uh, exercises. Okay, first we'll go with the in-text question. So the first question: why should a magnesium ribbon be clean before burning in air? Okay, so what you'll do, you'll write down the answers or how? So I'll just tell you, you can just see if you want to write in the short, you can just start. Okay. So why should a magnesium ribbon be cleaned before burning in air? So magnesium, the ribbon, okay, it should be cleaned before burning in air because the magnesium metal, okay, it reacts with the atmospheric oxygen, okay, which is present. And thus, if it reacts with the atmospheric oxygen, it forms magnesium oxide, that is MgO layer, which is very stable compound. So because of that, in order to prevent further reaction with oxygen, it is necessary to clean the ribbon by removing the layer of MgO. So whenever magnesium ribbon, whenever you want to heat it or if you want to burn it in the air, okay, so before burning you have to what you have to do, the magnesium it will react with the air, okay, which is present in the atmosphere, and it forms a magnesium oxide. So the layer is very stable, it is very stable. So in order to prevent the further reactions with oxygen, it is therefore necessary to clean the ribbon by to remove the layer of MgO. Okay. So the first question, it goes like this. So why it should be clean? Because the air, in air, what is present? Oxygen is present, air is present, right? So oxygen is present in the air. So Mg, it reacts with oxygen, it forms a MgO. So Mg plus O gives you MgO, and this forms a stable compound. This forms a stable compound. So this further prevents to react it with the it will further react. It will further prevent it to react with further oxygen. So because of that, it should be clean. So we should clean the magnesium ribbon before burning in the air. So this is the answer. Then so next is write the balance equation for the following chemical equations. First is hydrogen plus fluorine giving you hydrogen chloride. Yes, you can try how to write the balance equation. So this is in the form of word, okay, word sentence form. So you have to write in the equation form. Hydrogen, how do you represent hydrogen? Okay, yes, how do you write hydrogen?
Ma'am, H2.
Yes, it will be H2, hydrogen H2, okay, plus chlorine is Cl2, giving you 2 HCl, okay, giving you 2 HCl. So this was a balanced equation. So you can see H2 is how much? Hydrogen here are 2, hydrogen, chlorine, hydrogen, chlorine. Hydrogen here are 2, chlorine are 2. Here hydrogen are 2, chlorine are 2. So this is a balanced equation. Okay, so I have told the first one, second one, you have to tell me. Barium chloride. Yes, how to write barium chloride? So first was H2 plus Cl2 giving you 2 HCl. Now, second one, barium chloride. Barium is Ba. Chloride is Cl2. Okay, barium chloride plus plus aluminium sulfate. What is aluminium? Aluminium is Al. Okay. What is sulfate? Aluminium sulfate Al. See here, aluminium is plus 3. Sulfate is SO4 minus 2. Sulfate is SO4 minus 2. How to write? So here plus 3, right? So the charge you have to write 3. This will be 2 and you have to crisscross it. So it will be what? Al2SO4 thrice, right? So this is aluminium sulfate. So Al2SO4 thrice. Understood? So whenever you have unequal charges, it should be crisscross. Okay, it should be crisscross. So you have to write the charges below. Al plus 3, write 3 below of Al. SO4 minus 2, write 2 below of sulfate. Okay, then crisscross. You have to just crisscross it. You will get Al2SO4 thrice. So this is aluminium sulfate. Next, barium sulfate. Barium is what? Ba plus 2. Sulfate is SO4 minus 2. So 2, this 2. So it will get cancelled, right? So this will get cancelled because both are having same charges. So it will be BaSO4, right? So this will be BaSO4. So this will be BaSO4. Understood? Okay, then aluminium chloride. Okay, what is aluminium chloride? Aluminium, again, aluminium is Al plus 3. Chloride is Cl minus 1. Okay, then aluminium 3, Cl here is 1. Crisscross, this will be what? AlCl3. Okay, this will be AlCl3. I'll write here barium sulfate also, Ba plus 2, SO4 minus 2. So this will be 2, this will be 2, this get cancels. Okay, so this get cancels. So this will be BaSO4. Understood? So this will be BaSO4. This will be AlCl3 because they are having unequal charges. Okay, they will have unequal charges. So it will be crisscross. Now BaCl2 here also I'll write for BaCl2, Ba plus 2, Cl minus 1. So 2, 1. So crisscross. So this will be BaCl2. Okay, then aluminium chloride is what? AlCl3. Now balance it. Balance the reaction. Yes, balance the reaction. Yes, balance the reaction. So, till here it is clear.
Ma'am, 3 BaCl.
Yeah, till here this is clear. I'll go further. I'll show you next. Till here, everyone, this is clear till
Yes, ma'am.
here. Okay. So, how to write the charges and all, you have understood how to write the compounds. Okay. So this is clear now. How to write aluminium sulfate, barium chloride, how to crisscross, everything is clear. So now we'll write the how to balance it. Okay, we'll see how to balance it now. Now here, okay, here. Now here, what all are there? BaCl, aluminium, okay, then sulfur, oxygen. Sorry, sulfate only will take together. So this will be sulfur and oxygen separately it will be. Then here BaSOAlCl, or I'll write the same pattern here also. BaCl, Al, S and O. Okay. Now here barium are how many? Here barium are 1. Here barium is 1. Chloride are 2. Here chloride are 3. Here aluminum is how many? Aluminum are 2. Here aluminum is 1. Sulfur is 3. Okay, sulfur is 3. Here sulfur is 1. Okay, your oxygen are 4 3s are 12. Okay, oxygen are 12. Your oxygen is 4. Now, how to balance it? Here, what you have to do? Here, how many are there? Chloride are 3. Okay, here chloride are 2. So, what I will do here? This I will multiply it by 3. Okay, this I will multiply it by 3. So 3 BaCl2. So how many your barium becomes 3? Now this becomes 3 2s are 6. Okay, this becomes 3 2s are 6. Now here if I multiply this by 2 here, because again this will be 3 2s are 6. Okay, so here this will be 3 2s are 6. Then aluminum will be 2. So aluminum are 2 here. Chloride is 6. Now barium, I should again do this by also 3 only. Okay, because here also barium are 3. Now barium will be 3. Here barium is 3. Chloride is 6. Here chloride are 6. Aluminum is 2. Now sulfur is 3. Oxygen is 12. Now we have to do for aluminum sulfate. Okay, so this will be oxygen are how many now? Oxygen here you counted 4 3s are 12. So oxygen is also, just see oxygen now. So sulfur, how many are there? Sulfur are 3 and oxygen is also 12. So the it is balanced now. Understood? So this is the way you have to balance. So you can see now both the side the number of atoms are balanced. So they are same. Okay, so 3. So what is the equation? So the equation is 3 BaCl2, okay, plus Al2SO4 thrice plus 3 BaCSO4 plus 2 AlCl3. So this is our equation. So we'll go for the next one, third one. So third one is sodium plus water giving you sodium hydroxide plus hydrogen. Sodium is what? Na. What is water? H2O giving you. What is sodium? Sodium is Na. Hydroxide means what? OH. Okay, plus hydrogen means H2. So now balance it. Na is how much? Na is 1. Okay, hydrogen is 2. Oxygen is 1. Here Na is 1. Oxygen is 1. Hydrogen is 3. Balance this. Simplest.
Ma'am, 2Na plus 2H2 is equal to 2NaOH plus H2.
Na.
Ma'am, 2Na plus 2H2 is equal to
2Na plus
2NaOH.
2H2. Correct. 2, here 2 and here 2. Okay, so 2Na, so this will be 2Na, here also 2Na, then 2H2 means this will become 4, oxygen will become 2. Here if I calculate, oxygen will be this and 2 plus this will be 4. Okay, 2 and this will be 4. Yes, so the it is balanced. So this is correct. Okay, so our equation will be 2Na plus 2H2O plus 2NaOH plus 2 H2. Okay, so this is our 3 equations. I hope you have understood this. Okay, so we'll go with the next one. Write the balanced chemical equation with the state symbols for the following equation. So these are the equations. For this, you have to write the state symbols. State symbols means which the physical state, okay, whether it is solid, liquid, or gaseous. You have to write the with a balanced chemical equation. You have to also write the state symbols for this. So the first is solutions of barium chloride and sodium sulfate in water react to give you insoluble barium sulfate and the solution of sodium chloride. Now solutions of barium chloride. First we'll write what all are the reactants. So reactant is barium chloride and sodium sulfate in water. Okay, in water. So it gives you what? Barium sulfate and sodium chloride. So we'll write it down. So I'll write it down. So barium chloride. Barium is what? Ba plus 2. Chloride is what? Cl minus. Okay. So what will be the formula? So formula will be so Ba. I'll write it here. So Ba plus 2 and Cl minus 1. So 2. This will be 1. So just crisscross. So it will be BaCl2. Okay, so this is our barium chloride. So this is our first one. Now is sodium sulfate. Sodium sulfate is what? Na, and sulfate is what? SO4 minus 2. So Na will be plus 1. So plus 1, this will be 2. So again crisscross. So whenever you have charges different, it will be crisscross. So what will be? Na2SO4. Okay, Na2SO4. So this will be our next compound. Okay, Na2SO4. So this is our first one. So this is our second one. Now third is barium sulfate. Barium sulfate again Ba plus 2 and sulfate is SO4 minus 2. So Ba plus 2, SO4 minus 2. So both will get cancelled. So it will be BaSO4. Both the charges are same. Okay, it will be plus 2 minus 2 means it will get cancelled. So this will be what? It will be okay, so Ba plus 2 and minus 2 it will get cancelled and this form BaSO4. So this is our third one. And fourth is sodium chloride. Sodium is plus Na plus, chloride is Cl minus. So plus 1 minus 1 also get cancelled and this will be NaCl. So these are our 4. Okay, so 2 reactants, 2 products. So we'll write now. So barium chloride. Okay, barium chloride. So how will write barium chloride? So your BaCl2. Then plus sodium sulfate. So it will be Na2SO4. Okay, giving you barium sulfate, BaSO4 plus what is sodium chloride is NaCl. Yes, write the balanced equation. Tell me the balanced equation. Ba is 1, 1. Chloride are 2 here. So to balance these 2 chlorides, I will write here 2 NaCl. Okay. Now after writing 2 chlorides are balanced, Na will be 2. Here Na is also 2. Sulfate is 1. Here also sulfate is 1. So the equation is balanced. Okay. So this is the way you are going to write it. Now next is what? So both all are solid. So this will be S. Okay, so this will be S. So state symbols for the following reactions. Okay. Next. Understood? We'll go for the next one. One more we'll write and then we'll stop. Understood?
Yes.
Okay. So we'll go for the next one. Next is sodium hydroxide solution reacts with hydrochloric acid to produce sodium chloride and water. So these are our products and these are our reactants. So sodium hydroxide. Sodium hydroxide is what? Na plus, hydroxide is OH minus. Okay, plus 1 minus 1. So it becomes NaOH plus. It reacts with hydrochloric acid. Hydrochloric acid is HCl. Okay, hydrochloric acid to produces what? It produces sodium chloride. So sodium is Na, chloride is Cl minus, and water is H2O. Now see whether it is balanced or no. Na is 1. Okay, Na is 1. Oxygen is 1. Hydrogen is 2. Chloride is 1. Na is 1. Oxygen is 1. Hydrogen is 2. And chloride is 1. Okay, so this is a balanced equation. So if I write the state, so this will be solid. This will be liquid. Okay, this will be solid. And this will be liquid. Okay, so like this. Sorry, this will be gaseous. HCl will be gaseous, and this will be your state of the symbol. Understood? Okay, so like this, you have to write the balanced equation. So we'll next question is, a solution of a substance X is used for whitewashing. So which is the substance which is used for whitewashing? The substance which is used for whitewashing. Whitewashing means before paints for the walls. Okay, when the building is newly constructed, before painting the walls, they give you whitewash for the walls. Okay, it is called as whitewashing. Okay, so with what, which substance or which solution of the substance it is used for whitewashing? It is quicklime. Okay, it is quicklime. So quicklime or what? Calcium oxide. So remember this, very important. Okay, so quicklime or calcium oxide. So a solution of a substance X which is used for whitewashing. Whitewashing is nothing but whenever newly constructed buildings are there, before painting, they give a whitewash for the walls. Okay, so that is done by quicklime. Quicklime or calcium oxide. And what, so name the substance X and write its formula. So what is the substance X? The substance X is quicklime or calcium oxide. What is the formula? It is CaO. Okay, the formula is CaO. And what is the substance X? The substance X is quicklime or calcium oxide. Okay, then write the reaction of the substance X named in 1 above the water. So whenever it reacts with water, so calcium oxide plus water, okay. So if it reacts with water, it forms calcium hydroxide. Okay, it forms what? It forms calcium hydroxide. So you have to, so they have asked, write the reaction with the substance X with the water. So calcium oxide, when it reacts with water, it forms calcium hydroxide. I hope this is understood. Okay, so remaining in-text questions we'll do in the next class and followed by the exercises. Okay, is it clear?
Yes, ma'am.
Okay, fine then. So we'll stop the class here. Okay, thank you, students.